Hi, and welcome to my video on maximum word problems, level 1. This is number 2. And as in these problems were done probably in pre-calculus, could be done in grade 12 or grade 11, but the only difference is now I'm going to do them doing the derivative. Find the greatest possible amount by which a number exceeds its square. So we're going to let x be the number. So the greatest possible amount, I'm going to put m amount as am, and the greatest possible amount by which a number, which is x, exceeds its square. So exceeds the subtraction. So the number is how much larger than its square. So now that we have the amount, so we can do the derivative of that amount, and we get x, derivative of x is x, derivative of x squared is 2x. So this derivative, we make the derivative equal to 0, so that means 1 minus 2x is equal to 0. Negative 2x is equal to negative 1. Divide by negative 2, x is a half. So the number is a half by which the number exceeds its square. So the amount am is equal to, and we write down x minus x squared. So when x is 1/2, so we sub 1/2 into the place of x. So 1/2 minus 1/2 squared is 1/4. So the common denominator is 4. So that's 2 over 4 minus 1 over 4. And that comes out to be 1/4. So the number is a half, which this occurs for the greatest amount. And the amount of difference is 1/4. Number 2, we have a rectangular garden here divided into 3 parts. And 72 feet of fencing is used to construct the enclosed rectangles. Find the maximum area that can be enclosed. Well, one way that I do this is that I call this length x and this width, whatever you wish, in relation to the big field. This is the width of the field, and there's 4 parts, and this whole distance here is y. So that's one way that you can do it, and this is y. So what we have is that we have an area, or we have, let's look at the parameter first to make the difference. The parameter, P, is 72 feet, and the perimeter is, there's x, is 4 x's, and 2 y's is the total distance, the total amount of fencing being used in each of these parts. So that means that 4x plus 2y is equal to 72. Now we have an equation with x's and y's in it. So we solve the equation for y, so y equals negative 4x plus 72. Divide by 2, I get negative 2x plus 36. But we want to find the maximum area that it can close. So the area of this rectangular garden, or rectangular field, or rectangular plot, whatever you want to call it, the area is length times width, which is the width times the length, the same thing, x times y, or y times x. So that's the area. Now you notice the area is a function of x and y. So if we substitute y as 2x plus 36, now the area is 2x squared plus 36x. So now, because we took the parameter equation and solved for y, subbed it in here, the area is now a function of x, which is the width of the field. Notice we're using x's and y's here. We could use w and length, and got the area in terms of the width w and worked it out the same way. But A lot of these problems like to use x all the time. So the derivative is the area. Derivative is prime. So we get the derivative of the area in terms of x. So that's negative 2 times 2 is negative 4x. Derivative of 36x is 36. So if we let the derivative a prime equal to 0, we will have negative 4x plus 36 equals 0. Negative 4x equals negative 36. Divided by negative 4x is 9. So notice that the area as a function of x is like a parabola, because that's an area. And we have negative 2, a negative here, and that means that this area is acting as a maximum value, and it has maximum area here, and that's because this is negative. And so the derivative is the slope of the tangent, so the slope of the tangent is 0 at a value of 9. That's the peak point, that's the maximum value, maximum point. So we can plug 9 in and get the point, but we don't need the y value yet. We do need the y value, but what I'm trying to get at, this is the vertex of, or the highest value point for this area. So the area we have now, the area is x times y, but I don't have y yet. So we have y here. So y is equal to negative 2x plus 36. So x is 9, so we put 9 in. So we get negative 18 plus 36, which is 18. So the area is x, which is 9, times y, which is 18. And so the area comes out to be 162 when you multiply. And again, this is feet. So this is feet, y is 18 feet, and the area is square feet. So the maximum area enclosed by the 72 meters of fencing on this rectangular plot here, field, whatever you want to call it, is 162, the maximum area that you enclose. And again, that brings us to the end of another video. And if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my vertex, and the content. It's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.